right, welcome to our lesson on rotations. So today we're going to be able to perform a rotation of any point around the origin in a coordinate plane. So if we look at these examples here, we can see on the example on the left, we're rotating this 180 degrees. So if I was to flip my paper completely around, it would be the same. And then the example on the right, we're only rotating it 90 degrees, and we're going 90 degrees counterclockwise. So how to perform a rotation? First, we're going to make sure our plots are pointed on the coordinate plane, and then we're going to actually rotate the paper. And we're going to think of our paper as a clock when we rotate these. We're going to write down the new coordinates, and then turn it back to normal and plot those. So let's see how this looks in action. And we're going to rotate the point L, -2, 4, 90 degrees clockwise. So the first thing we want to do is make sure it's all plotted. I can see L, it's plotted on my graph. Perfect. Clockwise. So think of this as being a clock. So we're going to rotate our paper this direction. And we're going to go 90 degrees. Now we're looking at this, what we would think of as being sideways. It's just a new perspective. Write down your new coordinate of L. So we're going to call this L prime because it's the transformed or the rotated point. And now put your coordinates down. So now it is 4, 2. I go over 4, up 2. Rotate the paper back. And now we're going to plot that point we just wrote down. 4, 2. And label it L prime. And I'll write it right side up over here for you. And that's how you do a rotation. We're going to do some more just for practice. So rotate the point P, -3, -2, 90 degrees counterclockwise. So counterclockwise would go backwards on a clock. So if I think of this as being a clock, we want to go this direction, 90 degrees. So now I'm going to rotate my paper counterclockwise 90 degrees. And now find that new coordinate of P. So now this is all sideways, and that's okay. Where P is at, it is right 2 and down 3. So P prime, right 2, down 3. Rotate the paper back for normal and plot that point. Right 2, down 3. P prime. And we can see on here that if I was going around, that P to P prime did indeed go counterclockwise. What if I wanted to rotate a segment, though? So if I want to rotate a segment, we're just going to do it for both coordinate points. So this is 180 degrees. So 180 degrees means we're going to pick our paper up and turn it completely upside down. Now list the new K and W coordinates. K prime, left 1, up 1, -1, +1. W prime, left 4, down 3, -4, -3. Once you've listed and written those down, pick your paper back up and rotate back to normal. Now plot those points. So K prime was -1, 1. And W prime, -4, -3. And make sure you draw that segment in K prime, W prime. So that would be 180 degrees. And because 180 degrees is halfway all the way over, it doesn't matter if you go clockwise or counterclockwise. All right, here's an example for you to try. We want 90 degrees clockwise. So make sure that you rotate and you go in the correct direction. Clockwise would be like a clock runs. So go ahead, push pause, try this problem out on your own. All right, so I gave you the arrow to indicate which way you wanted to rotate this. So I'm going to grab my paper and rotate it 90 degrees clockwise and write down the new Q prime coordinate. Write 5, down 2. 5, negative 2. And now, back to normal, and plot that point. 5, negative 2, Q prime. Now, we also have scenarios like this where it wants us to describe our transformation. So if I wanted to describe this transformation, remember our pre-image does not have the primes. So this would be our start, and our image has the primes. So this is our end. So this is going to be a rotation because it does not have the same orientation, which means I'm going from here, this direction. This direction here, if I finish that circle, that's counterclockwise, which we can abbreviate CCW. So now we just have to find how far. Did we go 90 degrees or did we go 180 degrees? We only moved one quadrant. So we started here in quadrant 2, we moved to quadrant 3. So that would be 90 degrees counterclockwise. But we could also describe this as a clockwise rotation. If I was to start here and come clockwise, well, now I went through 3 quadrants, so 270 degrees clockwise. So you could do it in either direction. You can describe these clockwise or counterclockwise. It does not matter, but make sure you understand how those two relate together, okay? So here's one for you to try. Describe the transformation. So I need a degree measure and a direction. And the direction would be clockwise or counterclockwise. So take a moment, try it out. How far am I rotating this figure? So let's look at this problem. This image on the lower right, that's our start. That's our pre-image because it does not have primes. And the upper left is our end or our image because it has those little prime apostrophes there. So I could describe this clockwise going like this, and I went 2 quadrants, which would be 180 degrees. Or we can talk about this being counterclockwise, and we still move 2 quadrants, 180 degrees counterclockwise. So it doesn't matter which way you use it, and you could even just say 180 degrees, because the direction doesn't matter when you do 180. So a few things to remember. Rotating your paper is going to be extremely, extremely helpful, and make sure you think of clocks. Which way does the clock run? And remember that rotations can go in either direction. You could go counterclockwise or clockwise, but make sure you get the degree or the measure correct. That's it for today.